Okay, so welcome back. We're working through the notes for finding extrema of functions, and we're doing that graphically. And in this example, example 3, we're using a TI-84 graphing calculator to find the exact or the approximation of the extrema. You could use a TI-83 graphing calculator if you have that emulator on your laptops that we put on the first week of school, right? That will work exactly the same way as what we're doing on the TI-84 in the notes. Or if you're looking at that in that foldable notes booklet that we got in the last lesson for finding zeros and extrema with technology, in there you'll find instructions not just for the TI-84 but also for using GeoGebra online. That's an online graphing calculator, and there's detailed instructions in that foldable for how to do that. You want to avoid Desmos, however, for these examples, because when you're doing the online practice, you're going to be asked to round to 4 decimal places. Desmos will only give you 2 to 3 decimal places. In GeoGebra, it will let you set the decimal place value to anywhere, from 1 decimal all the way up to like 12. So you want to stick to GeoGebra and set the decimals to show you at least 4 or 5 so that you can round correctly. Okay, so looking at our graphing calculator, we're going to work through this example together. We're going to find the extrema for the function x cubed minus 7x plus 1. So we're going to start in the y equals here and type in that function. So x to the 3rd power minus 7x and then plus 1. Okay, to see what that looks like on the graph, we would go to zoom, and then zoom 6 is our standard -10 to 10 window in both the x and y axis. And if you're having a hard time seeing where these zeros are, because that's helpful when you're going to come up with intervals for your local extrema, you can go to the window button and then just stretch out your x-axis a little bit by changing these. So I'm going to make this a -5 and a +5. And now when I press graph, we're going to be able to see this function stretched out a little bit better. So now I can see here's -1, -2, -3, right? It looks like my my local maximum or relative maximum is between -2 and -1, right? When I'm looking for the local minimum, that appears to be between +1 and +2. So stretching out your window can really help you narrow in on those intervals. Okay, to find these extrema, I have to do them one at a time, because when I go to the calculate menu by pressing second trace, see here number 3 is minimum, number 4 is maximum. So I can only look at one at a time. So I'm going to start with the minimum by arrowing down to number 3 and pressing enter. And now it's going to ask me 3 questions here at the bottom, just like it did when we were approximating zeros with the calculator in our last lesson. So the first question is, what's the left bound of the interval of x values where this extrema is? And if I count over from my origin, here's 1, 2, it looks like my extrema, my minimum is between those bounds. So my left bound, I'm going to use +1 and press enter. Then my right bound, I'll use +2 and press enter, and see how it puts some arrows here, right? I just want to make sure that that minimum is between those arrows that mark off that interval. Okay, the third question is, do I want to make a guess? And I don't really care about guessing, so I just press enter. And now it shows me down at the bottom here, my minimum is at approximately 1.5275239, and the y is approximately -6.128451. Okay, that minimum value is the y value, and we're going to round that to 4 decimal places in the notes. So if we want to round to 4 decimal places, then I need to look at the 5th. So here's 1, 2, 3, 4. The 5th decimal place is a 5. So that means I have a relative minimum. So relative min. And since I rounded, I'm going to use an approximately equal instead of exactly equal. And rounding to 4 decimal places, since the fifth is a 5, I round up to negative 6.128, and then that 4 becomes a 5, right? Because I'm rounding that 4th decimal up since the fifth is a 5. Okay, now to find the relative maximum, I'm going to go back to second trace to open my calculate menu and arrow down to number 4, which is maximum, and press enter. And again, it's asking me for a left bound, but now it wants the left bound for this maximum. So -1, -2, so I'm going to type in -2 for my left bound. My right bound then would be -1. I press enter. Okay, I check that my maximum is within that interval that I designated, and then I don't care about guessing, so I press enter, and there is my relative maximum at 8.12845511. Okay, so again, to round to 4 decimal places, I want to look at the fifth. So 1, 2, 8, 4, and then the fifth decimal place is a 5. So I'm going to round up. So I have a relative or local maximum of approximately, because I'm rounding, 8.1285. Okay. So that's how we use the TI-84 in order to approximate the extrema. Okay, so I'd like you to pause the video and go ahead and try example 4 on the back of the notes booklet on your own using TI-84 or TI-83, or you could use GeoGebra online in order to find these extrema. So go ahead and resume the video once you've given that a try, and we'll work through it together to check your work. Okay, so now that we're back, we're going to go to the y equals, and this numerator is a trinomial, so I'm going to put that inside of parentheses. So x to the, that should be x to the second power, and then plus 4x plus 4, that's my numerator. Okay, the denominator is a binomial, so that also needs to be grouped inside of parentheses. So we've got the quantity x plus 1 in the denominator. Okay, to take a look at that graph, I'm going to type in zoom 6, and that's what it looks like. Okay, I'm going to go to the window and change my dimensions so I can get a little closer in there to see what the bounds look like. So in my window, I'm going to change my x's to go from -5 to 3, and my y's, I think I'll go from -5 to 7. Okay, just picking values that'll let me zoom in a little closer to see where these are. Okay, so now I'm going to look for my my relative maximum here first. So I'll go to second calculate, and down to number 4 is maximum, and it's asking for a left bound and a right bound. It looks to me like this relative extrema may actually be an x-intercept, one of the zeros of this function, and sometimes when that happens, if you use integer bounds for your left and right bound, you'll get a divide by 0 error. So I'm going to avoid that by just going a little bit to the left and a little bit to the right. So this looks like it's at -2. I'm going to type in -2.8 for my left bound, and then -1.5, say, for my right bound. And I just want to check that that relative extrema is in that interval denoted by those arrows, and it looks like it is. So I press enter for the guess, and there's my maximum at -2, 0. Okay, if you want to sketch that on the graph, right, we'd go to -2, 0, and that would be my relative max. Okay, so that relative max is equal to 0. You could replace that equals with the word of, since it's exact. We didn't have to round it. Okay, and we'll go back to that calculator. Okay, then I'm going to go to second calculate, and now I'm going to look for the relative minimum. Press enter. So my relative minimum is, looks like it's somewhere between -1 and 1. I can't tell though from this picture whether maybe the y-intercept where there's 0, something, like maybe 4, if that is my my local minimum or not. And again, sometimes when you use integer bounds for things that are on a 0, you might get a divide by 0 error. So it's helpful in that case to pick decimal values for your integer, or sorry, for your left and right bound. So I'm going to do, instead of -1, I'm going to do -0.7, for example. And then my right bound, maybe I'll do 0.6, right? I'm just picking random decimals to avoid those integer endpoints since it might be right on that axis. Okay, then I press enter for my guess, and here is my minimum, y equals 4. Now, the x value here, this is scientific notation because of that e. So 4.7087 e to the -7. That means that there are 7 decimal places in front of this this decimal here. So that's 0.00000, right? 7 of those in front of this, which rounds to 0. The algorithm that the calculator is using to approximate these extrema, it's taking slices of the bounds that we gave, kind of finding it halfway, finding halfway, finding halfway, and that algorithm is approximating each time. So sometimes we don't get exactly 0 or exactly an integer here, and you have to interpret that result. So if I want to confirm that this minimum is in fact 0,4, I can do that looking at the table of ordered pairs. So if I go to second table, and then I can arrow down here to, there it is, 0,4. So see how that scientific notation, it really is exactly 0. It's just the algorithm was rounding and gave us an approximation. So I now see that 0,4 is my relative minimum or local minima. So I have a relative min equal to +4. Okay, then we could see from the graph when we looked at that picture that this curve is coming along the vertical asymptote, bending along that extrema, and then heading along that oblique asymptote. Right, oblique asymptotes are slanted asymptotes. They shape the graph much like horizontal asymptotes. So when we get to the unit on polynomials and rational functions in Unit 3, we're going to look at how to find the equation of that oblique asymptote. But for now, since we're just focused on extrema, we're just going to make sure that our curve stays inside of those asymptotes. So it's decreasing and then goes through that relative min at 4. And that would be the top half of my hyperbola. And then the right half of the hyperbola is increasing, then turns at -2 in the range, and then comes down along that vertical asymptote. So we can see, since these ends are going up to positive infinity and down to negative infinity, there is no absolute extrema, only relative. So for absolute extrema, we would say that there are none. So that brings us to the secret question for this lesson. You're going to use graphing technology. It could be a graphing calculator, or you could use GeoGebra. If you're using GeoGebra online, make sure you set the decimals in the settings to show at least 5 decimal places so that you can round to 4 decimal places when needed. And avoid using Desmos because Desmos will not let you adjust your decimal places. So either a graphing calculator or GeoGebra